Hello everyone. In this video we will do an example with several parts related to permutations and different situations that come up while doing permutation problems. So here we have a JK class with 10 girls and 7 boys, and then Miss Gray, the teacher of the class, tries to form a line of different conditions. So the first part is that in how many ways Miss Gray can form a line of 17 students. Well, know that we have 17 students, and now we are basically forming a line with 17 students. Yes, and well, that will give me what? The number here will be basically the number of permutations. Yes, a line is permuted first person, second person, and so on. We have 7 objects and we are forming permutations of 17 objects or people, and we are forming a line or a permutations of 17. So that's 17 factorial. In part 2, we want to form such that she wants to form a line of 17 students so that all girls are together. So they are together. So we are not going to count the cases that, for example, it starts with one girl and then a boy and then other girls. So that couldn't be. So this is not just a permutation without any condition. Here, to count these cases, we will give you 2 methods. Method 1, I will call it a grouping trick. Actually, in both of them we are using grouping trick, but what you will see usually I'll call this is method 1. So to form such a line, we will divide the action of forming such a line into 2 pieces. In step 1, forget the boys, okay? Form a group of girls and call them just one new member of the group. So a group girls into one person or one object. So let me 1G. Okay, now you have 7 boys and then you add this group of G as one person to this group of 7. So form a line of 7 boys and 1G. That 1G itself has 10 students in it, but forget what is inside that. So we have 7 boys and 1G. That way, the number of ways we can do that, we have basically 8 objects and we are forming a line out of 7. But we are not done. We have not said that what is the order of the girls in this group. So step 2 is put the girls in G into an order or into a line. Wherever the G happens to be in the line, now I want to see what is the order of the girls in that G. So there are 10 girls and we have to form them in a line. That's 10 factorial. Then you apply fundamental counting principle. Number of such lines is going to be 8 factorial times 10 factorial. That's method 1. There is also another method which kind of I like it. So method 2 is that So we forget girls completely. So step one is that form a line of 7 boys. Okay, for a moment, forget how many girls we have. This will give us 7 factorial. And then step 2 is that, okay, so now you have 7 boys in place. You come choose the place that you want to insert girls into the line, or bringing the girls. So you have 7 already, 1, 2, 3, 4, 5, 6, 7 boys in place. Now I want to see, am I going to put girls here, 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 or all these things here? So that is fix the location of girls. How do we fix it? Well, just choose one of these 8 spots, 6 in between, 1 on each side. This will be 8. But we are not done yet. So we know where our boys, we know where our girls are supposed to be, but we don't know what is the order of the girls. So in the step 3, form a line of 10 girls in the given in the given location in the line. No, doesn't matter where we choose. Now we have a separate action. Put girls in a line. The number of ways we can do that is 10 factorial. So fundamental counting principle then tells me that the number of such lines is equal to 7 factorial times 8, the number 8, not 8 factorial, and then times 10 factorial. And for a second you look up there, oh, but you found something different in method 1. You found 8 factorial times 10 factorial. You're right, but if you look carefully here, 7 factorial times 8 is 8 factorial. And that is, you're seeing why the first method and second method giving us the same number. They should give us the same number, yes? So that was part 2. Let's do part 3. In how many different ways can Miss Gray form a line of 17 students with Hannah and James not being next to each other? So to solve this one, this not being should give you the hint that probably doing a complement trick will help us here. So, or counting indirectly, complement trick. What does it say? It says that if you're counting the number of ways, number of lines with H and J not to be next to each other, you can, instead of doing that, you count number of all possible lines minus number of lines in which H and J are next to each other. Why I'm choosing to count when they are next to each other? Remember part 2, grouping trick will help me to find this number. And number of lines is easy because that's just permutation. So let me just write now. This is going to be 17 permutation, the number of all possible lines of 17 out of 17 students. That's going to be 17 factorial. Minus, how about the number of lines that H and J are together? Okay, here again we will do 2 steps. Step 1, form group of H and j. Okay, and um, and form a line using, you see, I take out Hannah and James, then in total we will have 15 students. Then I have one group. Instead of Hannah and James considering them as two different, we consider them one group of H and J. So first I do that. So you see that there's 16 object and we have 16 factorial here. In step 2, however, we come and choose what is the order in the group H and G. So fix the order in group H and G. Basically, we already chosen where are they. Now we want to choose is H to the left or to the right of J. So this is, there are two objects, we are finding the number of permutations of 2. So as a result, the number of lines with H and J together is equal to 16 factorial times 2 factorial. So complement trick says that then the number of such lines that we are interested in to count is 17 factorial minus 16 factorial times 2 factorial. There's a simplification here. I will write it. I can factor out 16 factorial from the first one. The remaining will be 17, and then from the second one 2 factorial, but 2 factorial is 2 itself. So there is another way of writing this, which will be 16 factorial times 15. Okay. And then, well, just that tells me that there is another way of doing this. So I will leave that, find an alternative way to complete this example. So that is something you can do. Just look at the part 2 of what we did above, so you can kind of come up with the idea. It's similar, a little bit different, but you can do that. Okay. In part 4, we are looking for a number of ways that Ms. Gray can form a line of 10 students in which includes Hannah but not James. So what should we do in this case? So we have total 17 objects, yes? Now, we put aside James and we put aside Hannah, okay? So we will have, so then step 1. We put aside Hannah, we put aside James for a moment. Then there are 15 remaining students. Form a line of 9 out of 15 students. Well, we are excluding H and J. Okay. So we found, so there are 15 students and we want to form a line of 9. Why 9? Because I want to bring in Hannah and add to the line that I formed in the step 2. Step 2, insert or fix the location of Hannah in the line formed in part in step 1. So in part one, in the step one, we have 15 in total, and we want to form a line, permutation 9 out of 15. This will be 15 minus 9 factorial. In the second part, we have, okay, now we have 9 objects, 9 students in the line, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we want to bring in Hana and insert Hana in the line. So Hana can go there, 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 either or, and that will go up to there. How many possibilities we have for place of Hana? Well, there are 10 of them, not 10 factorial, only 10 spots that we can insert Hana. So by fundamental counting principle, we know that number of such lines is going to be 15 factorial over 15 minus 6 is what? Minus 9 is 6 factorial times just number 10. Yes, you can do a little bit of simplification here. For example, we can write 6 factorial as 5, 4, 3, and 2, and 1. And then with 10, you can cancel this, that. And the number we find here is 15 factorial over 6 times 4 is 24 times 3. This is 72. Yes, and that is the number that we found for the number of ways we can form a line of 10 out of 17 such that Hana is there but not James. Okay, so these were the examples, different tricks and different techniques that you can use while trying to count different forms of arrangements or permutations.